Welcome to episode 1 of the Extract Data podcast powered by Zyte. I'm John, your host, and my guest today is a long-standing team member in Zyte. He's worked across many different departments and has a wealth of experience and knowledge in web scraping. Our conversation today is focusing around data quality, and there's some really interesting things in here which I think you're going to enjoy. I'm interested to know how you got into programming and how you ended up working at Zyte, because I know that you were one of the first external employees.
Right, so my name is Artur Sadurski, and actually I'm a linguist by education, right? So the question about how I got into programming is spot on. Because previously I've been working with a localization company, so we were dealing with translations on mass scale. And I was already into quality back then, because that was about bringing the good quality of translations, right? And because the scale was that big, we also had to deal with automated means of testing those translations. So the manual ones weren't enough, and I got more and more into automating that, which led to at some point I started with just regular expressions and that kind of automation, but it led more and more into real programming, and that's how I started. But then I just wanted to switch completely into programming. My main focus then was artificial intelligence, machine translation at first. And that's what led me outside of the translation industry and into Zyte. Yes, I was one of the... I'm with Zyte for more than 10 years now. I've done multiple positions here, so goalkeeper, striker, and all the other parts, and also software development, of course. I was also in solution architecture. Also team leading, solo projects, things like that. And I ended up being in the QA department, responsible for data quality.
Yeah, you've done a lot of different jobs in the industry, which is always find quite fascinating. So you're now working in the QA with data quality. What does for those of us that probably have ignored data quality for far too long, what does data quality actually mean to you, and what does it look like?
It's mainly about setting the expectations, right, and adjusting to what you actually need, because it really may mean something different for any project, right? Some of the projects might be more focused towards the broad range, so of the data, right? So what we focus on is completeness, or how broad can our crawls be, just to get as much data as possible. For some of them, it's exactly the other way around. So you want to be really precise, just target the data that you need, but it has to be really pristine. So I know that's a vague answer, but I would say that, there's no silver bullet, no one size fits all solution.
Yeah.
It really is. I see it rather like a slider, or even like a complicated set of sliders, maybe.
Yeah, having worked in a different side of this industry for a while, there is never one answer that fits everything. So I totally sympathize with that. I guess then it's kind of like making sure that the data points that are agreed, that schema is reproduced correctly for the client, right?
Yeah, and there's quite a lot of talk around making the schema precise, right? So is what we are going to acquire actually what the client really needs. So and for a lot of those cases, the client really knows what they want, knows what they need, but sometimes it's more like you do your best. So for those cases, we just apply the defaults, and those defaults usually tend to work really well.
Yeah, I can imagine for businesses or clients that have not really delved too much into this, trying to understand what they actually want is probably quite difficult. For those people who aren't, the risks of not really looking at your data properly and having some kind of quality processes and Q&A it must be like pretty big to ignore this sort of thing.
Oh, right. I would say they usually bite you the most in the further you go in the process without inspecting the data, right, or just managing the quality. So the sooner you take a look at it, you do your inspections, you know what you're dealing with, the better, because if you catch the problems late, then you usually have to redo a lot of the things earlier in the pipeline.
Yeah, a lot of things to undo. What sort of problems would you likely to catch then? Would it just be the wrong information in the wrong part of the data, or perhaps you're not extracting the right thing across every page?
Yeah, I would say yes. I would say this the consistency is something that is hard to catch early even, but you see that late in your pipelines. Let's say you are building a model on something like even recognizing colors, for instance, but you get and you gather all those colors, but it seems like in 20% of the items it's not the color that was actually acquired there. So then you know that your models will probably not be as good as you want, and it's like waste of all the data that you gathered. So that's the quicker you find out that something is wrong, so sooner in the pipelines, the better it gets. So the detection techniques are actually what matters here.
What sort of things are the detection techniques? What do you use to figure out what's going on?
Oh yeah, so that depends on the type of data, right? Because we've had some of those techniques have been there for ages, which are like the outlier detection for numerical data, but for instance, even for lengths of the strings, we have the typical guardrails, which you can find in the JSON schemalette minimum maximum values. For outlier detection, we have also like minimum and maximum values, but also something employed from pure statistics. So the outlier with interquartile range or with z-scores, that all works really well. I mean, the more basic it is, the better it works. It's just that it usually doesn't really fit a lot of data types. But for instance, with that kind of data that I talked about earlier, for instance, if you have semantic data, like with colors, right? So that's something that used to be really hard to catch. You needed a separate model to be able to find that kind of semantic inconsistencies or things like that. And now there is a time with large language models that you can actually catch that quite easily and with not that much coding involved. So that's a
I suppose.
breakthrough.
Yeah, absolutely. I mean, how do you know what a color is? What it's described as in one piece of data could be completely different to how it's described in another one. I can imagine that makes it quite difficult to, without the LLM, to figure out what is and what isn't supposed to be there.
Exactly, and they do know.
Yeah, I guess they can give you a certain degree of accuracy as well, to fit in with the tolerance of what is acceptable within the data quality.
Oh yeah. Another part is that consistency. That notion, right? Because an LLM can even take entire record, read it, comprehend it, compare one field to another, and say something doesn't really fit there. So that's also like a detection technique that we use for just finding out about any possible mistakes that we've made with acquiring the data. So really, with large language models, there came like a new field of tests that we can employ.
Oh yeah, absolutely. You mentioned outliers, and I guess that one sticks in my head because it kind of makes the most sense to me. Looking at things that are statistically anomalies. When you're pulling the data through from whatever source in through your pipeline, are you constantly reevaluating what an outlier looks like as you get more and more data?
That's the case, yeah. With the outlier techniques, you usually need the entire data set to be able to find what the middle ground is and what is the actual outlier. So yeah, that applies to that full data set tests. But if, for instance, if you've done a project long enough, or it's a type of a project, then yes, you can have those data points from previous runs, right? But with outlier techniques, there's always something that you need to have as the basis. So it's not very suitable for those on the fly tests that you can run for every record, for instance.
How do you figure out then? Let's say you're looking at some data that's coming through that's like constantly being scraped from X amount of sources. How do you know what's going on, and where do you sort of measure it? I guess you're just constantly monitoring via monitoring software or code that you've written to put into the spiders.
We do have monitors which run constantly during the scraping, right? And that's the first line of defense, I would say. And they do a really good job with that first line. So that's where we try to catch errors early. But those are those simple techniques that we can employ there, right? But for other parts of the process, the more complicated the tests become, and the more complicated the issues that we can detect are. That happens later in the process, usually with more data and more of those cross-relational parts of the process. So yeah, we do have. It actually depends on the project, because you need to fit the pipelines into what's really necessary. But usually we do also use a kind of because there's a monitoring layer and something like an overview of the alerts, right? So for the overview of the alerts, we do employ different software there. In some projects, that's a bespoke solution. For some projects, we just use Sentry and act on what's happening there. So that really depends. Actually, the bespoke solutions are quite frequent here.
I'm curious, like, take it outside of the context of web scraping for a little bit. Are there like standards across data quality and Q&A that are, that come into it, or is it really just by, like a project by project basis? Is there anything you can borrow from other industries that they do really well that have crossed over?
That's quite an interesting topic, because you can, that's all data, and usually we work on a product, right? So that concept of quality is quite abstract. So something that you can apply to each and every product. And there are detection techniques and principles and standards that really carry over all the industries. For instance, we use exactly the same practices as the car manufacturers, for instance, right? Because why not? It works there. It works with our data. Like there's a principle, one of the curious ones, right? So for instance, how do you know that your data set is perfect? So how many records do you need to inspect so that you can say with utmost certainty that is perfect? So there is no mathematical rule for that, because in maths you would go with, there is actually no finite value. You actually need to inspect the entire data set, however big that is. But for instance, in car manufacturing, so how do you know that the batch of the cars is all right? It's in a good condition. So you do inspect 60 cars, and if you find 0 faults, that means that for in practical terms, most likely it's good enough, right? So we also employ those kinds of techniques in inspection of data, because it works really similar. Or for instance, some of the techniques that we use, for instance, for I experimented with some techniques for inspecting coverage. So do we actually download enough data from a website, and how much data there is? And what I took that from, it was pure biology. So if you, for instance, if you want to count the how big the herds are, right? So there are those catch and release techniques that are employed there. So you catch a subset of a herd, you mark them, and then after some time on the same territory, you need to make another hunt for the specimens, and you check how many of the specimens that you caught already have the mark. And we did the same things with the records on the website, just knowing that that's an ID that we have already seen. And it turns out that that's also a technique that can be used for checking the coverage.
That's fascinating.
There are techniques from the stock market, price predictions, that also can be employed to at least getting the baseline of the predictions. The techniques are quite universal usually, and that's really fascinating. Like whatever you heard of in an industry which seems totally unrelated, but you can actually bring it to your own. So
I guess the herd analogy, where I guess farmers need to know I think that's probably been working for them for hundreds and hundreds of years. So why not borrow it? I think that's fascinating. One of the things I've always wondered when I've been scraping data is to know, like, did I get everything or have I missed pages? And I guess it's these sorts of things that can give you that answer. That can let you know what your data looks like. Interesting. With the I just want to drop back to the cars thing for a second. With, like, you said 60 records, so we said you test 60 cars or 60 rows of data, I guess. Does that matter how big the data set is? Because obviously, like, the bigger the data set, the smaller percentage those 60 rows would be.
Yes, that's right. So if you want zero mistakes all over the place, that would be the rule. But usually the sample sizes differ depending on what you actually want to achieve, right? I would say that the case for not finding any issues is a rare one. So usually you would find issues within those 60 records, and so the sample sizes for the inspections are actually counted with the regular sample size formula, right? If you want metrics and you want them perform according to the regular statistics, then you would actually find a sample size which is usually greater than 60. We take in a lot of factors when it comes to sample size. There is the universal sample size formula dictates quite larger sample size for a data set, and if we were to inspect that manually, it's usually quite large. But one of the things that actually is there is that expected quality, right? If you don't really know anything about the quality of the data set that you had, that you would probably set it at the metric at 50%, and that's when the sample size gets really big. But we really usually the data sets are much better quality than at 50%, right? So you nudge that expectation a bit higher, like to 80 or 90%, and the sample size actually drops, and it doesn't really statistically it doesn't really do any harm to the evaluation, because you turn out to have really good confidence in the measurement at the end of the day. So even the sampling is well, I would say it's an experimental field when it comes to this, but that's there are also improvements that can be done there.
When you're checking through data for a client, do they sort of like rank the fields that they want to have the most accuracy versus maybe ones that are less important to them? Because when we're pulling data off of a website, there could be huge amounts of fields or of information, and for me, maybe half of them are mostly irrelevant but could be useful.
That's usually the case. So the client is usually most interested in a handful of fields, and that's really important, because depending on the use case, we get, let's say, the same kind of records, but different clients might use different fields for different purposes. Some of them might focus on, let's say, the product description only, because they are building some service that is going to read through the product descriptions. So then the descriptions need to be really the focus of the inspection. Some are more about the pricing and don't really care about descriptions at all. So yeah, that's exactly the use case. And depending on that, we also employ those different weights to the inspection, right? Like we focus more on the prices or on descriptions. That can also be taken into account when even calculating metrics. That issues with not that important fields get like a discounted penalty.
I guess I'm interested to know how businesses can start to implement more data quality into their workflows. There are a few kind of like staple things that you would consider mandatory when starting to look more into your data and want to improve the quality of it.
I would tie that a lot to kind of a visibility, right, of the data that you have, because if you don't really inspect that, then you just as I said at the beginning, you find out about your faults very late. So the sooner you get with the inspection, the more you find. That's one of the things. And well, there are frameworks that you can use which are more or less universal. For instance, well, in our industry, what we really have taken as a basis is just basic JSON schema validation, but there is, you can do really a lot of things with just that. Well, it's just that, there is no project without that, right? So that's like that cornerstone. And that's what we begin the work with. So the JSON schema validation, it seems like it's really already catching quite a lot of issues at even that stage.
Would that be like catching things like the wrong data formats and things like that?
Yes. So anything that you can, it's considered a very surface level test, and it is, but already at that kind of definition, that's somewhere that you already catch a lot of human type errors, right? So something that was just omitted or not thought about enough. You do have the formats, you have any kinds of constraints that you put on the data. So that might seem shallow, but it's actually
yeah, well, you've got to make sure that it's in a good enough order to be able to actually go any deeper into it. Otherwise, you're just going to fail further down the line as well.
Yeah, it's the foundation, right?
Exactly,
Something like that. And then it depends on what you actually want to achieve there. But later on, there are just tests that you would not perform with JSON schema, and it turns out that there are not that many of them left. So that's if you just go with JSON schema validation, you have most of your problems taken care of already.
What would you do then if you're looking through some data that's been, say, scraped from the web somewhere, and you find that it's extremely inconsistent and effectively no good? You just have to go straight back up the line to try and get it reacquired, re-extracted in a different way? Because obviously, it's come out of the website in a certain way and it's gone through whatever data pipelines and ended up, looking like it does. So it needs to be reevaluated. So that data is effectively useless.
Yeah. So, right. But first you celebrate that you've actually found it. Then you... but then, yes, there's that's the hard climb up the pipeline to find out where the issue is. Or maybe it might even be the case that it wasn't there at the beginning, right? So the expectations for the project were misaligned, for instance. So it can be digging back as far as to the foundations of the project, so the startup of it. But it really depends then on the use case. Sometimes the fix can be quite easy actually. There could be just a parameter that needs adjusting, and we're home. But now that will really
yeah. I guess you have to, if you go through your sample size and say you do your 60 records and you find some errors, I guess you have to bin the whole lot and start again, just in case that you might end up with more problems.
Yeah, usually there would be re-evaluations, like multiple iterative style improvements there. That's usually what happens, right? Because if you define bugs, well, they get fixed, but then you need to check whether they are really fixed. So there's a re-evaluation phase, right?
So I guess it looks quite different now than going forward compared to where you said you started with, regular expressions, to being able to use modern AI and LLM tooling. Can you give me a sense of how different those two things are from your very beginning experiences with regular expressions all the way up to now, where you can utilize the LLMs to help you?
Oh yeah, so that's completely different. With regular expressions are still like in JSON schema, for instance, right? So the foundation, but you can't really lock everything in regular expressions, especially when it comes to semantics, or even more descriptive qualities, I would say. So for instance, if you would say we don't want complex descriptions, right? So how do you define complex in a regular expression?
How do you
count
define
commas?
How would you even define complex description? I couldn't define it to you now.
Yeah. So but if you've read a description and you would have a sense that okay, that's a complex description, right? Or not that complex. So LLMs also have that sense of doing that. Or they can understand that, for instance, this seems like a mix-up of two different products, or something doesn't really fit here. So one of the things is that, yes, we can have a totally different range of tests based on different qualities of data. That's one. The other thing is that it's much easier to define. I mean, on one hand, it's easier because you can say complex descriptions, but on the other hand, you would want to explain to LLM what complex means to you, because otherwise it will have this general meaning.
Its own idea, yeah.
Yeah, and it will be most likely paranoid also about finding that everything becomes complex. But then at the end of the day, really this gives you a totally different style of inspecting the data. That's just even when it comes to the creativity, I would say, of the tests. Currently with LLMs, you can actually get creative. Previously, you only had regular expressions, and if you the top of your creativity was to count the commas in the sentence to know that it's quite complex or something.
Give me some examples of creativity in the testing. Then I'm curious.
Well, for instance, we do have even with colors, you can get quite creative. Like if you do know that the colors, for instance, of paint have pretty innovative names. So it won't be red and blue. It will be, like Icelandic pink or something like that. Whatever that is, but you know that
I'm sure it exists.
I'm also like, and there's no way you could fit that into a regular expression, but you can, with just a touch of subtle poetry, you could actually put it into a prompt into an LLM, give a couple of examples, and it will really work quite well with those even creative names.
I didn't think poetry was going to come up in this conversation at all. But
See,
there you go.
That's totally where linguistic leads to.
I must give you a pretty unique approach then with the linguistic skills. Having the analytic and linguistic seems to be, to me, quite separate anyway.
I think that's the same world. I mean, that's actually where the large language models bind the two worlds, right? It's like you have that pure structure of the language, which used to be hardly translatable into maths, but it used to be, well, we were finding ways to do that. And now, well, at that basic level, those are still numbers. So this is like the ultimate bridge between the two. Yeah, that's kind of fascinating.
Yeah, it really is. Yeah, really is. I've always just had this separation in my mind of mathematics and then languages being completely separate. But as you say, it's a real crossover of worlds at the moment. If you can, I think I'd be interested to know any stories that you might have about where bad data quality has, you've come across it and had issues, or maybe good or something like that. I guess as much as you can say without giving away too much.
Oh. I mean, one thing with the data quality is it's like I see this as a very transparent being, like with your car. You don't know that it's broken until it breaks down, right? So until it does, you kind of have a transparent view on the reliability of your car, right? It's
still going, so therefore everything's fine, right?
Right. So and that's sometimes the how it goes with data quality. So if so, for instance, when it comes to the stories, usually those are the bad ones, right?
I guess, yeah, because if all the data was good, then that was just it. It was fine. There was nothing.
Yeah, exactly.
It's only when it goes wrong that you kind of sticks out. So it's more like just, I guess, fixing problems more than anything else.
Yeah, exactly. So that's usually there are just bad stories, but those bad stories usually come from misunderstandings. So miscommunication, usually, right? Miscommunication or managing expectations incorrectly. So there have been just problems with data quality that originated in those wrong weights. So for instance, the client's use case is actually about descriptions, but we focus on the prices because usually the clients really want the prices, right? But well, this client is different. They don't really care about the prices. Price is just like an additional data pointer. So that's where those bad stories start to appear, because, well, didn't really know that the description was that important, and we just gather what we usually do.
There's that human and there's that human side to it and everything, right? You don't know, you can't deliver what you haven't been told properly, or the client never gives you the right information type thing.
Yeah, there's I would say that there's enough. Again, that's where the linguistics comes into place. So the theory of the communication, there has to be enough context and the contact. It's all really interconnected.
Is there anything else then that people should really consider or think about when they're implementing data quality, or they can consider when they're looking at projects like this?
One thing I would recommend is to pick the right metrics, and usually you do, and just to align them with what you really need, what your use case is. We've been shifting our own data quality metrics more and more towards precision and recall, because they make this landscape of the quality like more visible, because with precision and recall you can see better what you're missing, what you're good at. And it's, I know it sometimes for some people it might be like that's not quite right, because it's a binary metric, right? So it could be quite harsh. But it turns out that this represents the quality quite well. And so when it comes to like choosing the right metrics for you, so when it comes to precision and recall, I would say that, well, there would be use cases that you just, with those two things, you would not need perfect ones, right? And that's really a good thing, because then you can, if you can define the level of the metrics that you want to achieve, then this really, it can even bring production costs down. It can bring the data inspection costs down too, because if you don't really need them perfect, then you invest less into inspecting them. So I could give you an example, for instance, right? So with precision and recall, so let's say you're on a Queen concert, and Freddie goes, "We will
rock you."
Yeah, you do know what's the thing. So you don't really need perfect recall on that, right? It wasn't perfect, Freddie. You missed like 2 words. So that's way below 100%. But then on the other hand, if Freddie went, we will eat breakfast, you would say, that's kind of not how it goes. And you kind of miss the point. Yeah, Freddie learned the lines. In this case, you need less of a recall, but more of a precision, right? So that was your use case. And well, so if you do in music industry, it's more about precision, I would say. Right, but that's the thing, right? For your use case, it might be completely the other way around. You would need better recall, but the precision might not be that as important, or just for certain fields. So that's also, it actually goes into a kind of a grid at the end of the day. And as I said, that set of sliders to actually set. So, and basing on that, if you set those expectations correctly, then this makes it much more manageable then in your project to just get to those set metrics. So I would say that's one of the really, really important aspects.
Great, yeah. So I think we're getting quite close up on time here. So I guess for me the final thing is just to get your thoughts and understand what you think the future of data quality and Q&A is going to look like. Are we living it now with the LLMs, or is it just going to continue down this path with more improvements in, precision and everything like that?
Yeah, so getting future oriented. So observing the pace of the development of the large language models, and how we are adding more capabilities onto them, right? So the context windows just grows. But they also they can see, right? So you can send a screenshot and inspect that. So I would see that there is like another level or range of the tests that can emerge anytime now. There would probably be, again, more capabilities on the large language models that even shifted to another level. One of the things is the memory, right? Because if you can teach a model what is wrong, what is right, then it could actually do a lot of the things for you. Also, the things that we used to need humans for, and now we don't, or we need less. I still see this as like an assistance than a replacement. That's the.
I think that's my sentiment too. Even from a slightly different position in the industry, I think it's more of an assistant rather than anything else. But no, it's been really interesting. I think I've learned a lot from this conversation, actually, personally myself. So really appreciate your time talking to me, Artur. And thank you very much.
Thank you. It's been a pleasure.